Hello, everyone. As Nadia introduced me very kindly, my name is Lucas. I work at Centrifuge. I'm based in New York, but very frequently here in Berlin. I'm very happy to talk to you today about privacy. Before I start, I'll give you a very quick introduction about what Centrifuge does, because I'll be referring to what we're doing a little bit. Essentially, we're building an operating system for companies to use to transact among each other, to use Ethereum for decentralized and trustless communication. What does that mean precisely? It means that I can send documents and receive documents such as invoices, payment notifications, purchase orders through our network without relying on a central entity. We do that with Ethereum, and we have our custom peer-to-peer protocol that is based on libp2p that is doing all of the privacy, the heavy lifting in the privacy. So this talk is about privacy, so I'll start with a very basic introduction. The definition of privacy is that it's a state or condition of being free from being observed or disturbed by other people. What does that mean for us as engineers in building dApps? For me, it means that whenever we're building something, we should focus on forcing the user to reveal as little information about whatever they're trying to do as possible. So if you can do something without sharing who you are, then make them do it without sharing who they are. Well, Matt Green, inventor of Zcash, used this on a slide recently. He said, well, like Bitcoin is like Twitter for your bank account. Well, what does that mean for us, like working with Ethereum? Is it Twitter for everything else? Is it Twitter for your life, everything you do? Well, let's hope not, and let's see how we can actually avoid it ending up that way. I could go on about why privacy is important all day and bore you to death, but I just want to give you two quick examples to show sort of like how privacy actually matters for you and how what we're sort of talking about. Example number one, Joe is using Coinbase to fund his Ethereum wallets that he then uses to trade kitties, breed them, sell them, but he also uses them to participate in discussion and fund political causes that might not always align with whatever his employer thinks. Well, this is all good and fine. Like his Coinbase is keeping his information private. He funds his Ethereum wallets with his bank account, but well, a few years down the road, Coinbase gets hacked, and now suddenly everything that is or was private is now public, including his contributions to those political causes. And well, good luck for Joe finding a new job with that information now out in the open. Example number two, Carla wants to go on vacation. She has had a very tough month at work and decides to splurge on a 5-star hotel and treat her to something. She makes a reservation on this decentralized travel site. Well, she hasn't booked her flight yet, so after she made that expensive hotel reservation, she heads back to Kayak and wants to book her flight. It turns out that her flight suddenly is 50% more expensive because Kayak saw that she bought an expensive hotel room and now thinks that, well, she probably can afford to pay much more for her flight than she actually would have to if Kayak didn't know this information. So let's get into let's talk about privacy and what is going on in Ethereum right now. Well, selling cats is kind of a thing people do, and it's kind of fun, but it's actually not really that important and also not that urgent. But well, the value of ETH is something that people talk about a lot, but it's also not that important. But we have important stuff going on, such as how we can make our smart contracts safer so people don't lose money or ETH doesn't get locked up, stuff like that. We definitely have this giant burning thing that is scalability that we all need to figure out for Ethereum and dApps to become popular, to actually like work it for everyone. But there's also this thing, privacy, that is like sort of off the radar, I would say, right now, because well, I agree we need to solve scalability first, but once we do that, for real-world usage, that's something beyond just trading kitties. Privacy is going to come very quickly, so let's make sure we do not miss the train on that and actually like start thinking about that now. At Centrifuge, we want to build, and we're working with companies, so they will be from day one asking us about privacy. So we've designed our protocol with that in mind. We're not... no, it's fine. So we built this. We built our protocol with zero metadata leakage and zero requirements for actually revealing anything on chain. We use sort of a two-layered architecture. We use Ethereum for identities and anchors. Anchors is what we call our commitments of the state that is off-chain. Ethereum, as you know, is public. It has a global consensus, which makes it really safe. But because of that, it's expensive. And the downside is also that it's public. Channels, sort of our layer 2 solutions, where we sort of use channels and state channels in the for document exchange. It's private, it's scalable, it has a high throughput, and it allows us both to achieve scalability and privacy. I'll go into a little bit in detail, but looking at what is the difference between those two? Blockchain consensus, you essentially publish your transaction, everyone can verify it, and therefore you have a high likelihood that it's respected by everyone, but it's also public to everyone. State channels, you only really go on chain when you have to, so either to settle certain things that have been coordinated in a state channel, or if you have a dispute, if the two parties or one of the party in a channel is not behaving the way they're supposed to. This moves all of the data, the heavy lifting off chain, and gives you the security sort of as a last resort to use on chain as a courthouse if you can't come to an agreement between just the members of the channel. How do we use this? Well, I mentioned libp2p. libp2p is a really cool utility. It's actually built by the guys at Protocol Labs. It powers IPFS, their distributed file system. It's a framework that lets you build apps that talk to each other over a peer-to-peer network quite easily, and it takes care of all these nasty things you, as an engineer, you really don't want to learn about and know about, such as NAT traversal, discovering other peers, protocol translation, etc. It also has this one feature that for us is quite important. It has a security layer that is very similar to SSL, TLS. It basically allows you to ensure that whoever you're talking to really is who they're talking to by verifying that they possess the private key to a public key. And I've mentioned that we keep our identities at Centrifuge on-chain. So imagine Alice and Bob wanting to interact with each other. They announce on Ethereum, this is the public key that I'm using. You can find me on libp2p with that key. And now when they want to talk to each other, Alice just needs to verify that Bob initiates a connection with the right key and vice versa. So this gives us a way to secure this off-chain communication quite easily. The other thing that we do in libp2p and that we then push to Ethereum are these sort of state commitments. We call those anchors, where essentially what you do is you hash the state and you commit that hash on chain, so that later on you can prove that that was what was agreed upon, that was the state that you had by revealing sort of the preimage of that hash. Now, let's dig a little bit deeper into anchors. But for that, I just need to give the obligatory explanation of what a Merkle tree is. A Merkle tree is really good at having large sets of data and proving that a certain element is part of that set. Merkle trees are used in every blockchain for at least one thing. For example, you can prove that your transaction was included in a block by submitting the Merkle tree that shows that this item is part of this Merkle root that's part of the block header. But we use it actually for something slightly different. In the end, we're still using a Merkle tree, but what we're doing is, well, if you look at an invoice, for example, it has certain fields such as the amount, the buyer, the supplier, the due date, etc. But what we do now is we construct this Merkle tree not just out of a number of different invoices, but we take each field of that invoice, we flatten it into a flat structure, and we create a Merkle tree out of that allows you to reveal, to share then, or to prove that a certain value of that invoice is whatever it is by submitting a Merkle proof for that field. And this is then what we anchor on chain. Those are our state commitments. So I've shown this graph before, but to summarize again, like instead of putting invoice items, we actually make this tree bigger. We have each individual field of the invoice that you can then say, I just want to show you who the supplier is of this invoice and what the amount is without telling you any of the line items or like the information that I want to keep private. We call that precise proofs. We've published a little bit of open source code on this that you can find on GitHub. To summarize, what we do with precise proofs is we actually allow you to validate transaction details instead of just a transaction signature in a larger block. So feel free to check it out, Centrifuge on GitHub. You'll find it. Now that I've sort of talked a bit about how we keep state off-chain and how we allow different entities, or how you can build something that allows different entities to communicate, well, there's certain times where you want to go on-chain and you actually want to have an interaction with a different dApp or like a decentralized exchange or whatnot. So you have to start building bridges that let you prove something that has existed only off-chain and sort of interact with it on-chain. And now I'll give you one example. We have NFTs. I hope everyone's familiar with those. NFTs are non-fungible tokens that you can sort of mint out of whatever you want, and then you can trade those and sell those with a standardized way. In the supply chain world, it's very common for companies to borrow money between the time that they submit an invoice to their customer and the time that it's actually due, so for those 30, 60, 90 days. And they would go to banks today, but there's actually no reason why we couldn't do that with sort of a supply chain finance dApp on Ethereum. Well, but as a supplier, I don't want to reveal the business I have on chain, right? But I would want to create an NFT that I can then sell. Well, we can use those precise proofs that I've mentioned so that the NFT registry can list a set of fields that they want to verify. As an example, I want to verify that this invoice has been accepted, that it's of a certain amount, etc. So as a supplier, I would submit that proof. I prove that I'm one of the owners of that document, meaning I am the supplier. That NFT registry can then verify the precise proof by going to those anchors that I've mentioned, and then can mint that token, and now as a supplier, I can sell that token and receive financing for an invoice without having to actually interact with the bank. And that bank knows that this NFT is backed by something that they can then later on verify by themselves going into the peer-to-peer network and requesting that document. So this is one of those bridges. Another bridge, different example, again, using the invoice as an example. Let's say I'm shipping something from Germany to New York. This is a very important big order for me, and I need to make sure that it arrives on time and it arrives not damaged, and if it gets lost, that I get redeemed for it, because I will go out of business if I don't. Well, so you would go to an insurance company and you would submit the information of what you're trying to insure. They would keep that data, probably in some of their archaic SAP system or like database that who knows what will happen to it. And then give you a price, you pay it, and then you're done with it. You could also go to this insurance dApp that is not privacy enabled. You could submit all of those details publicly, and the insurance dApp could verify itself or give you a price itself and make you pay that price, and then you could insure it. But actually, what you can do is you can use zero-knowledge proofs to do that in a way without revealing anything about the invoice at all. So I'll try to explain snarks in 30 seconds. Basically, the idea is that you can prove the correctness of a calculation or the correctness of certain statements without revealing what the values of those statements are. So in this example, I can prove to you that the invoice is, the origination address is in Germany and the destination is the United States, that the value is of $1,000, and that the output of this snark, for example, in this example, it would be the insurance amount is 2% of the invoice amount, because the price to insure an item from Germany to the US, according to the list that the insurance contract gives me, is 2%. So I can create this snark that anyone can verify that I've made this correct calculation that gives an output that says, okay, the insurance price is 2% of 1,000 of a transaction, is $20. It doesn't say 2%. It just says it's $20. What is behind it? All of the information that I've just said, the country, the amount, and the percentage, that is completely unknown. But as the insurance contract and anyone else for that matter can verify that this was a valid calculation of an insurance or an insurance fee. So what I can do is I can take this. I can create this SNARK, I prove the SNARK as a supplier, I take that along with the payment of those $20, I submit that to the insurance contract. That insurance contract verifies that there exists a hash on-chain of this document that I've just proven. I've requested insurance for, and by verifying that SNARK, it can just say, well, I accept your payment of $20. I don't know exactly what you're doing, where you're shipping it from, where you're shipping it to, but I know that you've given me the right price for whatever it is. Thus, being able to certify that I have insurance now and then allowing me to claim in case of damage without actually knowing anything at all. So those are like two of the examples that we use sort of to build bridges between our off-chain and on-chain protocol. I hope this was a bit of an insight and some idea that gives you ideas for how you could incorporate some of these technologies into your own product. But to summarize, there's always this on-chain, off-chain trade-off. On-chain, extremely secure, public, and you have this global state, so you can make sure that something is unique, but it's expensive and it's very hard to do privacy. However, if you want to scale, you're at some sooner or later forced to move off-chain or in some sort of side chain anyway. So that usually plays well with privacy, because if you move stuff off-chain, you can also make them private very easily. Global consensus is not always needed. In our example, a supplier and a buyer, they don't care about whatever the thousands of other Ethereum nodes that are validating the chain care about their transactions. As long as I know that Alice has signed my invoice, I'm fine. So it's actually not always needed. Think about how we can look at these problems in a way that you don't need to just assume that there's a global verification. Also, the examples I've mentioned, this is something we're working on right now. I would say the technology is already there. Look at libp2p, look at Socrates on Ethereum that lets you create snarks and validate those or verify those in smart contracts. And then much more is to come, but I'd encourage you to think about it that way. And lastly, if you're designing a protocol, if you're designing an application, it's a lot easier to make sure that it has privacy from day one than if you're trying to take something that is public and you try to tack on privacy with some sort of extra stuff. So that's it. Thank you for listening. You can find me on Twitter. You can email me. This is our website. I love to talk about privacy, so reach out to me, or